Hello! Right, so we'll work through the 6 examples now of integrating functions that are not necessarily easy to deal with. Now, we've got number 1 from the previous video, that if we want to integrate something of the form ax to the power of n in respect to x, then it's ax, we add 1 to the power, divide by the new power, have the constant c at the end of course of integration. That is how we integrate a standard function. Now, if we have a look at number 1, we've got the primitive, or the integral, of x to the 4. So the integral of x to the 4 dx, well, I can just write that as 1/5 x to the 5 plus c. You could have wrote that as x to the 5 over 5. There's also a valid answer to this question. For number 2, we've just got a constant out front, it doesn't really matter. So if we add 1 to 3x squared, so we have the integral of 3x squared dx, we have 3x cubed over 3, plus my constant c of integration. Obviously the 3 and the 3 will cancel each other out, so you've got cubes plus c. Alright, let's have a look at number 3. Not too much trickier because I've just got 2 terms, not much harder. I've got the integral of 2x plus 5 in respect to x. Doesn't matter how many terms you can have in there. If we have a look at that, 2x, or if I add 1 to 2x, it's technically 2x to the 1. So if I add 1, it's 2x squared, divided by that will give us just x squared. Now the primitive of 5, if you think about it, 5 is lots of 5x to the 0. Because x to the 0 we know is 1 from our index laws. So if I add 1 to the power, I get 5x to the 1 divided by 1. Well, 5x to the 1 is just 5x, divided by 1 doesn't do anything, so I just get 5x out. My constant c of integration. That's number 3. If I look at number 4, we have 4 terms, not much different here. I've got the integral of 5x cubed minus 7x to the 8, plus 5x, and minus 8 at the end. Doesn't change anything. If I add 1, I get 5x to the 4 divided by that. So I get 5x to the 4 over 4. And I get minus 7x to the 9 over 9. I get 5 over 2x squared. Working through these, and I get a minus 8x and my constant c of integration at the end, of course. Do not forget your constant of integration. This is a rant that I go on a lot with my kids who make this mistake. You must have the constant of integration. If you don't, then you get 0 marks. So it's worth it, just put that extra letter in. Number 5, I've got the integral of 3 over x squared. Yeah, we've got 5. Now, 3 over x squared, using your index laws, I can prepare the vegetables before I integrate, and I get 3x to the minus 2. Now, the integral of that, if I add 1, I get minus 1. 3 over minus 1 just gives us minus 3x to the minus 1. And my constant of integration. Also, I could write that as minus 3 over x if I wanted to. That's it back in the form I was given. Totally valid approach. Get rid of that. Have a look at number 6. I've got the integral of the 4th root of x dx. Now, the 4th root of x, using our index laws, I could rewrite that as x to the power of a quarter. Integrated in respect to x. Now, add 1 to a quarter is 4 quarters of a quarter, so 5 quarters. Divided by that is the same as multiplying by the reciprocal, which is 4/5. So we get 4/5 x to the 5 over 4. And each of these, you can check if you've done it right, because you can quickly differentiate in your head. So you can multiply the 4/5 by the 5 quarters and take essentially 4 quarters away, so taking 1 away from the power. If you go and differentiate that, obviously the constant just goes away. Alright? So that's how we can integrate an indefinite integral.